Welcome to another A-Level Computer Science video with me, Mr Goff, for MrGoff.com. This video will focus on the concept of big data. Big data is a catch-all term for data that won't fit the usual containers. Big data can be described in terms of three characteristics. Volume, where it is too big to fit into a single server. Velocity, where data is streaming and there's milliseconds to respond. Variety, where data is in many forms such as structured data, unstructured data, text, and even multimedia. The most difficult aspect of big data really involves its lack of structure. This lack of structure poses challenges because analyzing the data is made significantly more difficult, meaning machine learning techniques are needed to discern patterns in the data and to extract useful information. Also, relational databases are not appropriate because they require the data to fit into a row and column format, and relational databases also don't scale well when the data won't fit on one server. Velocity refers to the speed at which new data is generated. With data coming in from network sensors, smartphones, video surveillance, mouse clicks, and more, data is being generated very quickly. The statistics below show the amount of data that is generated in a single minute on the internet in 2022. These figures just keep growing year on year. When data sizes are so big that they cannot fit on a single server, the processing must be distributed across more than one machine. Functional programming is a solution because it makes it easier to write correct and efficient distributed code that can be distributed to run across more than one server. It is the features that functional programming languages support that allow you to program correct and efficient distributed code. Features such as immutable data structures. This means an object's state can't be changed once it's created, so functions always return the same result. Statelessness. This means functions have no side effects, so it does not matter how often or in what order they are called, they will still return the same result. And the ability to have higher order functions. A higher order function takes one or more functions as a parameter and/or returns a function as a result. Fact-based models are used to represent data as facts and the relationships between them. Each fact within a fact-based model for representing data captures a single piece of information. Immutable facts are recorded with timestamps. This means facts can never be changed. Data is never deleted. The dataset continues to grow, but the timestamps allow us to discern what is the current data. Older data and the timestamps themselves are often not represented in a fact-based model. Graph schema are used for capturing the structure of a dataset in a visual way. A graph schema is made up of nodes and edges, each of which may have its own properties. Nodes may have their properties written within them, as you see in the example on the left, or have their properties attached by dotted lines, as you see in the larger example. Relationships are shown as arrows, or they could be aligned with no arrowheads, meaning that relationship is bidirectional. Properties for the relationships are written along the lines or arrows. Some of the benefits of fact-based models include the fact that new nodes and relationships can be added without affecting the existing data. And where searching a relational database of a huge size takes a very long time, with a fact-based model, we can do this by finding our starting node and following the links to where we want to go. This makes it highly useful for tasks like mapping friendship groups on social media networks, and recommending products by analyzing purchases and past orders. That brings us to the end of this video on big data. Join me again soon when I'll be starting to have a look at functional programming. Use the resources at mrgoff.com to help you revise computer science. And until next time, it's bye for now.